Hello and welcome again. And in this lecture, we were going to solve another question with or about frames and machines. So this is a frame really made up of two members, like so. The members are pinned at the top and also pinned at their bottoms, and it's like sitting on the slope of a hill at A and C, and there is one force having a magnitude of 2 kilonewtons acting on the right hand member at D, acting horizontally at D. Some dimensions: short height 3 meters, a horizontal spans 4 meters and 4 meters. And now vertically on the right hand side, the force of 2 kilonewtons is 6 meters from the support at C and 3 meters from the top of the frame. Again, by neglecting the mass of the members, we are asked to calculate the X and Y components of the force supported by the pin at C. So that is the support at the lower right end of the frame. Now again, if we remove the supports from this frame, we will have two members AB and BDC that are pinned at B and free at the other ends at A and C. So one can easily see that this frame is non-rigid, and hence we can try to see if we can solve for any of the external reaction forces. Unfortunately, A and C, the two pins, do not line up either horizontally or vertically, so therefore we cannot solve for any external forces, and therefore we will start by splitting the frame into its components. Again, we should draw the components by maintaining the shape of the frame. So in other words, drawing like an exploded view of the frame. A, B, C, D, and then the reaction forces at A. Again, I'm just guessing their directions. You can also draw them with their positive directions. It's also a way of doing that. And now you can see that because A and C do not line up, if we write moment equations at A or C on the whole frame, we would not be able to solve for any of the other reactions. We will always end up with two unknowns in one equation. That's why we split the frame, and now we also have to show the internal reactions at B, Bx, and By with opposite direction on each of the free body diagrams, one on the left side and two on the right side. So now starting writing equations of equilibrium on, say, the second free body diagram on the right side, where we have already a known force, the 2 kilonewton force, we can sum the moments at C, and if we do so, we can then establish an equation that would relate the internal reaction forces at B, By, and Bx. So let's call this equation number 1. In a similar fashion, if we jump now to free body diagram 1, we can sum the moments at A, and then we can establish another equation in terms of By and the Bx. And we can also determine this equation if we realize that member AB is actually a bent to force member. So we will establish a similar equation from that perspective, like equation number 2 here on the screen. So now we have two simultaneous equations, and we can, for example, solve for bx from the second equation and then substitute the expression of bx into the first equation. And once we do so, we will end up with an equation like this one, negative 4by plus 9 times negative 4/3 of by equals to 12. And of course we can solve very easily from these equations for by, which will be equal to negative 3/4 kilonewtons, meaning that by was wrong, its direction was wrong, whatever we assumed. And it will go upwards on free body diagram number 1, and bx is positive 1 kilonewton, so it will go to the right again on free body diagram number 1, with opposite directions, of course, on free body diagram number 2. Now we jump on to the second free body diagram and summing the force on the horizontal direction. That will give us the magnitude of Cx positively. So Cx is 1 kilonewton going from right to left. And finally, if we sum the forces also on the second free body diagram along the vertical direction, then we can solve for the y component of C, and this will result negative. So hence our original assumption that Cy goes downwards was wrong. So Cy will actually go up, and its magnitude is 3/4 kilonewtons. Now in the end, you would have to show the final results. I will not draw a separate set of free body diagrams, but you will have to do that and show the forces with their correct directions, and of course indicate their magnitudes, the magnitudes of these forces on the last final set of free body diagrams. You would have to do that as part of your final answer. So as you can see, this was another simple example for frames and machines. And I would like to thank you very much for watching this lecture, and I will see you at the next one.